Alcohols, multiple choice questions, aka A-level chemistry. So question 1, which statement is not correct about the industrial production of ethanol from ethene at 300 degrees Celsius? Oh, that's when I took a screenshot. The reaction is catalyzed by an acid. That is true. The reaction has 100% atom economy. Yeah, we're forming one product. That's true. An increase in temperature decreases the equilibrium yield of ethanol. While the forward reaction, because that delta H is negative, the forward reaction that tells me is exothermic. Therefore, if I increase temperature, it's going to shift to the endothermic direction, and therefore I'm going to have more of this, and therefore it will decrease the equilibrium yield of ethanol. So that's true. Therefore, the statement which is false is this one. And if we look at this, increase in pressure increases the value of Kc. If I just looked at that immediately, I would have known that's wrong, because only temperature can affect Kc or value of Kc. Next multiple choice question. Which compound is produced when 1-phenyl ethanol reacts with acidified potassium dichromate? 6. This is a very difficult question. And the only reason, when I go through it, I'm going to be confident because I watched a walkthrough and then I watched it again. And I think I did it again as well. It's a difficult question. But what I would suggest doing is first drawing this out. So, phenyl group. Right. Okay. And it is attached to ethanol. So methane, ethane. Right, that's perfectly fine, right? No, because it says 1-phenyl ethanol. So the OH group has to be attached to this carbon which is attached to the phenyl group. So it has to be here, the OH group. It has to be here. Therefore, that's the hydrogen. So if the OH group is here, what does that tell me? Well, this obviously would be a carbon. Obviously, in the cyclic structure, you don't include it, but it would be carbon. And the OH group has to be here because 1-phenyl ethanol. That tells me that is a secondary alcohol. That is a secondary alcohol. So if it's a secondary alcohol and it's reacting with acidified potassium dichromate, what is it going to form? Well, secondary alcohols form ketones, oxidize to form ketones. And therefore, all we have to do now is look for a ketone. That's an alcohol. That's an aldehyde because it's at the end of the carbon chain, carbonyl functional group. That is a ketone. You can clearly see it's in the middle. CO. And this is also an alcohol. The answer is C. But that is really difficult. Drawing it out, realizing, well, this OH group has to be attached to this first carbon. It's 1-phenyl ethanol because that carbon's attached to the phenyl group and the alcohol group. And then realize, okay, that's a secondary alcohol. And therefore, if it's going to react with acidified potassium dichromate, it's going to form a ketone. And therefore, the compound I'm looking for must be a ketone. Question 3. Which statement is correct about the production and use of ethanol as a biofuel? Biofuel ethanol is produced by the fermentation of glucose in the presence of yeast and air. It's purified by fractional distillation. That is true. No carbon dioxide is released. No, there is some carbon dioxide released. Burns with a cleaner flame. No. So the answer is B. Question 4. Okay. Which compound can be oxidized to form this? Now, Okay, so okay, so I can see that this is clearly a ketone, right? Because the CO is in the middle. So therefore, the carbonyl functional group. So therefore, which compound can be oxidized to form a ketone? Well, it must be a secondary alcohol. Secondary alcohols oxidized to form ketones, right? Secondary alcohol. So by this logic, all I have to do is look for the secondary alcohol. 2-methyl propane 1-ol, methane, ethane, propane, alcohol groups on the first carbon, CH3, H, H, H. I don't even need to do that. I can clearly see it's primary. This carbon only attached to 1. 2,2-dimethylpropanol, methane, ethane, propane, alcohol group, 2,2-dimethyl. Again, yeah, it might have two methyl groups attached to the second carbon. It's still a primary alcohol. C, methane, ethane, propane, butane, alcohol groups on the second carbon, and you've also got a methyl group on the second carbon. And then obviously fill in the hydrogens. Well, this carbon is tertiary. That's no good, and therefore the answer must be D. And if I look at D, methane, ethane, propane, butane, alcohol groups on the second carbon, methyl group on the third carbon, fill in the hydrogens, it quite clearly is secondaries. There we go. So the answer is 4D. I really like that question. I really like this question because, once you spot that's a ketone because the CO is in the middle of there, then you can quite easily be, okay, it's a ketone, and therefore the compound I'm looking for is secondary alcohol oxidized from ketone, and then just draw out the structures and you find out which one is secondary alcohol. Question 5. Which alcohol forms a mixture of alkenes when dehydrated? Remember, it's dehydrated reacted with concentrated sulfuric acid, like for example, ethanol, dehydrated to form ethene. And in some cases, we form a mixture of alkenes because the OH group can exist can exist in more places, so more than one possible product. With propane 1-ol, methane, ethane, propane, obviously this is how the reaction would go, and then it bond to H plus, etc., etc. You're only going to form one product. You're not going to only going to form one alkene. You're not going to form a mixture of alkenes. And I really do want to go through like the mechanism just to show you guys why. And I actually might do that. I went through it before on my notepad, so I'll just copy and paste it into the laptop screen. Ew. Okay, so propane 1-ol, ethane, it will take a while, so maybe not. But the idea, right? So you've got your lone pair electrons of oxygen, H plus, then you've got this, then you've got that, oxygen positive, and then this carbon is positive because that leaves as a water molecule, that carbon is positive, and then the left carbon spare electron wants to reform the double bond. It wants to form a double bond. It can form a double bond perfectly fine. However, it's not in the middle, is what I'm trying to say. Once the positive carbocation is in the middle, that's when you can form generally a mixture of alkenes. In this case, propane 2-ol, then propane, alcohol group here, bonds, perfectly fine, leaves, and then obviously same thing here, H2O molecule leaves, you've got a positive charge here, so surely it's propane 2-ol. However, if I form the double bond here, it's still going to be the same. So in this case, pent-1-ene, in this case, pent-1-ene. Completely symmetrical. pentwanene, pentwanene. And then obviously that. With pentan 1-ol, methane, ethane, propane, butane, pentane, alcohol group is on the first carbon, exactly the same as propane 1-ol. Electrons, bonds here, H+, then you've got this, and then you've got then the OH molecule leaves, carbon's positive, CO bond breaks, and now this carbon's positive, right? Well then, all that happens is you form a double bond there. And therefore, the answer must be pentan 2-ol. And if we look at pentan 2-ol, methane, ethane, propane, butane, pentane, on the second carbon, obviously, so that's where the positive charge is going to be, because you know the OH, oxygen with lone pair of electrons, bonds to the H+, oxygen positive, CO bond breaks. Now this carbon positive carbocation, you've got your H and H here. That can form a double bond here. It can also form a double bond here. And you might be like, Iman, didn't you just say before with this it doesn't matter? Yes, because pentwanene in this case, because it's completely symmetrical, yes, you could argue that is pentuene, methane, but then if I just start from here, that's pentwanene. So it actually isn't pentuene, it's pentwanene. So I can't actually form a mixture of alkenes in that case. Whereas in this case, I formed a double bond here, so I form the double bond here, or I form the double bond here. And they're not symmetrical, they're quite clearly in different positions. And therefore the answer is D. That is very tricky. One marker, multiple choice question. A lot of these questions are as well. But yeah, don't get confused between pentan 1-ol. Yes, it does, but if you think about it, or it's the same. All I've done is flipped it around, and if you can flip it around, it's the same. It's not an accident of each other. So yeah. Question 6. Which compound is produced when 1-phenyl ethanol reacts with acidified potassium dichromate? Repeat question. We go through it again. Perfect. Because this is a very difficult question. So you draw a phenyl group, obviously bonded to your ethanol, and obviously, like I said, the ethanol, the OH group, hydroxyl group must be attached to this first carbon because it's attached to phenyl group in here. And then if you look at this, well, that is a carbon there. Therefore, it is a secondary alcohol. And therefore, if it's a secondary alcohol, which compounds form when a secondary alcohol reacts with acidified potassium dichromate? Well, secondary alcohols oxidize, forming ketones. Therefore, we just look for the ketone. That's an alcohol, that's an aldehyde, and therefore that is a ketone. Yeah, and that is a carboxylic acid, so that is not it. Yeah, so therefore the answer is C. Question 7. In the UK, industrial ethanol is now produced by the direct hydration of ethene. This process has largely replaced the fermentation method, which is a likely reason for this change of method. Does not use a catalyst, produces ethanol by a slower reaction. No, why would that be the reason? Not use a catalyst, no. Employs milder conditions. No, not really. It's because it produces purer ethanol. Question 8. Which statement is correct about 2-methylbutane 1 on 2-methylbutane 2? They can be oxidized by reaction with acidified potassium dichromate. I can disprove that right now because methane, ethane, propane, butane, 2-methylbutane 2-ol, methyl groups on second carbon, OH groups there. That is a fill in the hydrogens. that is a tertiary alcohol. How can I oxidize a tertiary alcohol? You can't. If it's a secondary alcohol, sure, but it's not. It's a tertiary alcohol. And it says they can both be. This probably can, yeah. That is a, I think that's primary, it doesn't, or secondary. It's not a tertiary, but the other one, 2-methylbutane 2-al, can't. So therefore, they can't both be oxidized by acidified potassium dichromate. They can be formed by hydration of 2-methylbutyrene. They have 4 peaks in the 13C NMR spectrum. I haven't gone through that topic and I really want to go through it as well. I'm not sure about it. So I'm left with A and C, formed by hydration of 2-methylbutyrene. They can be formed by that.
No, it's not.
Well, if I hydrate 2-methylbutyrene, yeah, let's go for it. Why not? 2-methylbutyrene, but they can be formed by alkaline hydrolysis of esters. Alkaline hydrolysis of esters. Yes, that's true. But obviously, if you weren't sure, then you go through that, and then you can clearly see that they can't both be formed by hydration of 2-methylbutyrene. Question 9. Which alcohol can be oxidized by acidified potassium dichromate 6 but cannot be dehydrated by heating with concentrated sulfuric acid? Can be oxidized. So firstly, I would literally just find out what kind of alcohols there are. So butane, OH group, CH3, CH3, that is a primary, secondary, tertiary alcohol. I'll just do 3O alcohol, therefore can't be oxidized. This one, methane, ethane, propane, alcohol groups in first carbon, CH3, CH3, perfect, that is a primary alcohol, so it could be that. To look at the rest though, can't just jump. 2-methylpropane 2-al, methane, ethane, propane, OH group, CH3, that is a primary, secondary, tertiary alcohol. Same thing I said for A, 3O alcohol, and therefore can't be oxidized. Pentane 3-al, methane, ethane, propane, butane, pentane, third carbon, it is a secondary alcohol, 1, 2, so that is a secondary alcohol. And secondary alcohol obviously can be oxidized to form ketone. But it says which one can be that, but cannot be dehydrated. But dehydrated, if you think about it, primary alcohol but cannot be dehydrated by heating with concentrated sulfuric acid. Well, if you look at 2,2-dimethylpropane 1-al, this, filling the hydrogens, why not? So, dehydrated, oxidized but cannot be dehydrated with concentrated sulfuric acid. Dehydrated, well, if lone pair of electrons here bonded to here, bond to H plus, that leaves as water molecule, this carbon's positive, and then that's why it can't because you've got a methyl group here, when in reality you can only do it if there's a hydrogen here, and then you'd lose your hydrogen. But if you're here, in this case, yeah, you can't do that. So that cannot be dehydrated by heating with concentrated sulfuric acid. And that is the end of these multiple choice questions. Very difficult, but hopefully you found it useful.